This is a series where we explore some data analysis, some statistics. Now we're going to do it the easy way. We're going to use AI and we're going to use a modern research environment. We're going to use a Colab notebook, which is a form of a Jupyter notebook. Now if that sounds fancy, what it really is, it's like a Google Doc or a Word document in which you can do all the normal things that you could do in a Word document or Google Doc, but you can also add some code, and that makes it brilliant as a research document. Open research is what it's all about so that anyone can see the analysis that you did. So in the series, we're going to import some data and we're going to analyze that data all with the help of AI. Now along the way, I'm going to make some deliberate and not so deliberate mistakes just so that we can see how AI deals with those and how easily we can correct our mistakes. Now with Google Colab, you don't have to install anything on your system. Everything lives in your Google Drive. Now normally, I manage that all on my own system. I'll use something like Visual Studio Code. But when you first starting and you've never coded before, I think this Google Colab is a wonderful way to get started. You can learn some statistics, learn how to do data analysis, and how to use AI in a proper way to analyze your data. So in this first video, we're going to make sure that when we open our Google Drive, we have access to Google Colab, and we're going to import some data. Now that data file is going to be available to you. Just look at the description down below. There'll be a link to that data and you can play along. This is really easy and yet so powerful. I've opened my Google Drive. This should be very familiar to most of you. We can just click on New and we have Google Docs, Google Sheets, Google Slides, Google Forms. But what I want to use is not any of them. I want to use Google Colab. So I've opened a tab here for Google Colab. You can just go to colab.google and you can read a little bit more about it. It is hosted Jupyter notebooks. That's what it is. And that's what we're going to use in this demonstration. So if you click on New and you go down to More, I have Google Colab right there. If you do not see Google Colab, there's a couple of things that you can do. You can just click on this little button, Connect More Apps, and you can simply search for Colab. There we go. And you see it comes up over here, 83 million plus downloads already. You can just click on this button and install it. As you can see, I've already got it installed. You only need to do this once and then you'll always have that Colab or the ability to create a new Colab document, going to New, More, and then clicking on Google Colab. You can also do it by just opening one of these two tabs here. It's going to open an instance of Google Colab. Once you start using it, for instance, opening up one of the demonstration notebooks in here, it'll install it in your Google Drive as well. The safest way I think to go is just to go New, More, and then connect more apps. So since I do have Google Colab, I'm just going to create a new Colab document inside of this demonstrations folder that I've created on my Google Drive. And there we go. It might look slightly different to you. I've used this many times, but this is our Google Colab environment. On the left-hand side is just this blank slate. And there's one cell created in here. We can see the cell is demarcated in this rounded cornered rectangle. And we can either type code in here. If I hover just in the middle between these two, or just below it, you can see in the middle, you can above or below any cell, create a new cell, and you can create either a code cell or a text cell. So a code cell is going to contain code, and a text cell is going to contain just normal text that you can format, just like you would format text in a Word document. So you can have big, nice title, and then smaller font sizes for subtitles and sections, etc. You can add images, any sort of thing that you can think of, or many of the things that you can think of in a Word document, you can put inside of a text cell. You can also see that you can click on these little buttons here, add a code cell, add a text cell, etc. Just want to show you that there's a runtime button as well, where you can change your runtime type. And if you do that, we see I have Python, R, and Julia. Google Colab notebooks can run either of these three languages by spinning up a kernel of one of these languages. You also see that I have access to running on GPUs and TPUs. Now this is the Pro version of Colab. On the top left, you'll see Colab Pro. I do get access to that without having to pay because I do this through my university account. If you're creating large machine learning models, you can select one of the GPUs and set this high RAM toggle to high. We don't need any of that, and we're just going to use Python, so we're just going to use stick to the default Python 3. You can see there's a little connect button there. As soon as you hit that, it will spin up a kernel of Python, meaning it starts running Python on Google servers, and that's what you're going to use here. Or as soon as you run your first bit of code, it'll connect anyway, so don't we really have to worry about that. The right-hand pane here, there's Google Gemini, and we can just use Gemini. You'll see it's a normal little chatbot interface here, so you can start typing all your questions. If I go to the bottom right here, I have access to 2 models with this Pro version, 2.5 Flash and Gemini 3. Now I think these are peculiar sort of options, because the Gemini 3, I don't know which version of Gemini 3 this is, it doesn't say here. And so that might be slightly overkill and might take longer to execute. But 2.5 Flash, that's sort of underwhelming. That's not the best model that Gemini has, not particularly performant. And so those are our 2 options. I'm just stick to 2.5 Flash, but I would like to see a bit more granularity there, and as much as these choice with these models. But that's what we have. I'm just going to stick with Gemini 2.5 Flash. So here's our notebook. The first thing that I might want to do is just to give this notebook a new name. You can see at the moment it's called untitled 0.ipynb, and the ipynb extension, that stands for IPython Notebook, that was the previous name for Jupyter Notebooks when it was particular to Python, and that file extension of course is just stuck. So I'm just going to click on there, hold and drag so I can give it a new name, and I'm just going to call it demonstration. And so it's demonstration.ipynb. The first thing that I want to do is just right at the top. So I'm going to hover over this, cell that was there to start with. I'm going to hover in the middle on top of that cell and click on the text cell. And it says double click or enter to edit. I'm just going to double click there. And here you can see some familiar things. That's the toggle, the heading, the size of your font, bold, italic, insert a link, insert an image. You can see add numbered lists, add bulleted list, etc. So there's a couple of things that you can do, which really makes this an ideal environment. Jupyter Notebooks are the ideal environment for research. So I'm going to show you just to do this by hand. I'm going to use a single hashtag and then a space. That single hashtag with a space indicates the largest possible font size. So that's great for a title. So let's add a title to our notebook. And I'm just going to hit Shift Return or Shift and Enter, and that executes that cell. And now you can see it's a beautiful large font, and that's ideal for a title. So my title for my document is going to be Demonstrating Data Analysis using Google Colab and Gemini. What I would like to do is to add another little cell, a text cell below this title. So I'm going to hover in between these two, and I'm going to hit text. Now I'm going to use 2 hashtags in a space. That's the second largest font, and you can actually go up to 6 hashtags. That'll be the smallest sort of title or section font that you can have. I'm going to call this one Packages, and I'm going to hold down Shift and hit Return or Shift and Enter to execute that cell, and you can see that font is slightly smaller than the title font. So 1 hashtag, 2 hashtags, you can see sort of the size. I'm going to do the same thing again. I'm going to add a new text cell, and now I'm just going to add some normal text. So no hashtags whatsoever. It's just going to be normal text. So I'm going to type, we import the required Python packages. I'm going to hold down Shift and Return, and you can see it's just normal text. That's the normal font size, and you can just add lines and lines of just normal language inside of a text cell. Now there's a couple of things I'm going to do right in the beginning. I'm not going to use AI for that, because I think that wastes a little bit of time. I know Python, and within a short while, you'll be able to do the same. So I'm just going to type in a code cell now. So the cell that was pre-populated when I started this notebook, I'm eventually going to use that, and that is just a normal code cell. Now, as you can see there, I can start coding, or I can hit this button and say generate with AI, and we're going to do that a little bit later, and then we're going to type our prompt on the right-hand side. But for now, I'm just going to manually enter some code. And you see some code here that I've typed manually, and I'm going to run through this because it's not that difficult. I don't want to use AI to do that, although you can write a prompt to do all of this. But I think, once you've seen it once or twice, it'll be easy enough for you to do. Because this is slightly small, I'm just going to increase the font size of my whole interface. There we go, slightly bigger, and hopefully you can see a bit more, better now. So my first line of code is right there. I'll highlight that. It's import pandas as PD. That's the actual code. You'll see a space, then a hashtag, and another space. Now this hashtag and the hashtags that we've seen before, or pound symbol, that's not the same thing. When you use it inside of a text cell, that's going to determine the size of the font. When you use it inside of a code cell, it is a place where you can leave a note to yourself or someone else who writes your code. This is called code comments. And what the Python interpreter is going to do once in any line that it sees the hashtag symbol or the pound symbol, it's just going to ignore everything that follows, which means it is ideal to leave these little coding messages. So it says importing and manipulating data. So this import function is going to import this package called pandas. And I'm going to not want to write pandas every time because it's 1, 2, 3, 4, 5, 6 keystrokes. So I want to be a bit lazy. And so I'm going to use a namespace abbreviation, and that's what the as keyword is, and then just PD. So every time I want to use pandas, I don't want to type pandas, I can just write PD, just type PD. 2 keystrokes, much better. The next one is import numpy as NP, and numpy is for numerical calculations. Again, I don't want to type in NUMPY every time. I want to be lazy and just type NP, so it's just abbreviations. Now the next line of code is different. It says from SciPy, import stats. So in Python you will find that some of these packages have submodules, modules in them. And from SciPy, which is scientific Python, I want to import the whole package. In that package I only want to import the stats module, and stats is for statistical tests. Now I'm not going to say as, and I can do that, but stats is not usually abbreviated. That's fine, we can leave it as such. Now, the next one's going to be import matplotlib.pyplot. Now, this pyplot is a module of matplotlib. So I could have said from matplotlib import pyplot, but this is just another way to go about it. So I'm going to say import matplotlib.pyplot, and then I'm going to say as plt. So I don't have to write pyplot every time. I just use plt. Now, these are just conventions, and it's just great to see the different ways in which you can do this. And that's going to be for data visualization. And then matplotlib is a very big package, and the pyplot module is a very big module. And so Seaborn is a package that makes creating plots much easier than matplotlib, but it uses matplotlib behind the scenes. So we're just going to import that as well. So import Seaborn, and the common abbreviation that most people use is just SNS. And that this is going to be, for our, particularly for our statistical plots, just makes using matplotlib a bit easier. And that's how Python works. That's the beauty of Python, is that there are all these packages out there, and they just add functionality to the Python language. And I like to import them right at the beginning. All the packages that I want to do that in the beginning instead of using it where I need it the first time. Because if I look at that document again, I don't want these things to be scattered all over my research document. So I'm going to hit this little play button. You can also do Shift Enter, Shift Return. I'm going to hit this little play button there. And that's going to spin the little wheel, as you can see there. At the top right, you can see connecting. So it is starting a version of Python on the Google servers. That's running, and that's executing my code. And it sends it back to my screen to show. And so there we go. I see a little green tick mark there. Everything has been imported. So yes, I can use AI to do all of this, but it becomes second nature after a while. These are the common libraries or packages that we are going to use for most of our data analysis. So pretty standard, pretty easy to do. And I've left these little code comments just for the sake of interest and some information, but you certainly don't have to type them. The next thing I'm going to do is just to add a little text cell. And what I want to say is the following. We set the notebook to produce high resolution plots. I'm just doing a normal English sentence there. So that's in a text cell. I hit Shift Enter, and we can see that we set the notebook to produce high resolution plots. Once again, I'm going to show you a little bit of code. I'm not going to get the AI to write it for me. You certainly can write a prompt and the AI will do this for you. But I'm just going to do it manually. And there we go. %config inline backend with uppercase I and uppercase B dot figure underscore format equals, and then inside of single or double quotation marks, I'm going to write retina. And again, very simple. You can just memorize that. Again, you can get the AI to do this for you, but I'm just going to do it by hand. I'm just so used to it. And I do that at the beginning of my research documents, these notebooks. And that produces high resolution plots because I am using a high resolution screen, and I don't want those fuzzy low resolution plots. I want high resolution plots, and this is the code for that. This %config, it's called a magic command with a %, and that's to configure the notebook. So it's not, let's say, not really Python code. It is specific to these Jupyter notebooks, and that just creates the high resolution plots for me. The next thing I want to do is just to create another text cell. So I'm going to hover there, click on text, and this is what I want to add. So I've typed, we select the white grid theme for our plots. Now the Seaborn and Matplotlib have got many themes, and that just means you don't have to write a lot of code to get a certain look out of your plots. They're just these pre-formatted themes, and just, saves a little bit of time. And so I've typed sns.set_style, open close parentheses, and then in single or double quotation marks, you can write white grid. So that's the theme that I'm going to use. So what's going on here? Once again, you can get AI to do this, but it's so easy to do. Just do it by hand. So SNS, as we look back up here, that's short and abbreviation for Seaborn. So that says the Seaborn package dot, that's the notation we use in Python, use the set style function. So we know it's a function because it's got open close parentheses. That denotes this as a Python function. It doesn't exist in base Python, but it does exist inside of this package. So we've extended what Python can do. We've added a new function called set_style, which exists in this Seaborn package. And you can see the beauty of this ability to extend what the language can do. But I have to say, SNS dot, I have to tell the Python interpreter, this is not part of Python, so you'll have to go look in that package to find this function and know what to do with it. What we add inside of the parentheses, that's called an argument, that gives the information to this set_style function to be able to do its job. And it sees white grid there in quotation marks, which means this is a string, which is the fancy word for text. And that's the argument we're giving to the setStyle function. The setStyle function knows what to do. When I hover over that, you can see there's some tooltip appearing there, some information about the function. You can read that. And once again, I'm going to hold down Shift and hit Return or Shift Enter. Little green check mark there. The code was executed. Everything's good to go. So now my plots are going to have a specific look. Next thing I want to do, I want to keep things nice and neat. I'm going to add a text cell and then another 2 hashtags. So this is going to be my section headers. And I'm going to say import data. Shift Enter. And now you can see it's the same font size as the packages. And now you see we also have this little ability to close these sections just to keep things neat. So if I click on that, it's going to collapse. And now it looks nice and neat. You can just click on it to open it up again, close it back down. So let's get our data ready. I'm going to add a new text cell. And there we go. I've typed the data for this demonstration. This demonstration analysis is in a comma separated file. And it's called heartclass.csv. And I've put that in these little backticks. So you've got to look on your keyboard where you find these little backticks. Now those little backticks, they are about formatting. When I enter, or at least the Shift Enter or Shift Return, it's going to format what I've written there. Now these backticks, they format the text to look like coding text. And on the right hand side, you can see Google Colab is giving me a little bit of a preview of what this is going to be formatted as. So depending on which Jupyter notebooks you're using, you're going to get slightly different formatting. But you can see the font is different. This is a font that looks like the normal coding font. And these are just neat and nice little things you can do in a code cell to format your text. And so I'm going to say we import the file using the read underscore. And I should say, there we go. And hold down Shift and hit Enter Return. And you can see what Google Colab does, puts in a different font and puts this little rounded rectangle, rounded edge rectangle, cornered rectangle around this. And it's just nice, neat. It shows that, there's something different going on here. I'm referring to a specific file. I'm referring to a specific function that we're going to use, etc. Now, the next step is going to be to actually upload this data to Google so that we can use it in this notebook. Now, every time you run this notebook, you'll have to do that. Google's not going to save that file for you. You'll have to add that file every time. Which brings me to an important point. You have to look at the kind of arrangement your institution or your company or then yourself have with Google. Are they going to be able to look at these, use it in their AI training? get access to this data file, you'll have to be very careful. So in, let's say, in quotation marks, in real life, we will usually add synthetic data to a notebook such as this. We're not going to add real patient data to this folder. We can still create that code and all the analysis from the synthetic data, but then we'll download this notebook to a secure system and we'll let all the code is still there, but now we're just going to add the real patient data file. And that's one way to go about this. So be very careful what you upload here and what you have permission to upload. And the way that we're going to do this is if we go to the left-hand side, we see there's a little folder icon. It says files. When you hover over that, I'm going to click on that and we see there's a little upload button there. So upload to session storage, and that's only going to be available during the session. So next time, if you want to work on this notebook again, you have to re-import your data file. So I'm going to click on that. Now my folder window opened up. I'm not going to show my folder. There's lots of other files in there. And I just clicked on the appropriate file and it says a little warning, ensure that your files are saved elsewhere. This runtime files will be deleted when this runtime is terminated. Once again, as I said, it's not going to save this permanently, but I'm going to click on OK. And there you see that CSV file, comma separated values file. It's a type of spreadsheet file, remember, and that's the name of it. And it's now right there available for me to use. What I want to do is hover over this little 3 hamburger dots, click on that, and I'm going to say copy path because I want to tell this notebook where this file is saved, and it's now temporarily saved not on my system but on Google servers. So I need to know where this is. So I'm going to click on copy, and now again I can get AI to do this, but I'm just going to do this by hand. I'm going to write some code. I'm going to say file, which is just a variable name that I'm giving this file. And see, there's some auto completion there. That looks great to me. That's actually the code that I want. I'm not going to hit the tab key. Once you hit the tab key, that is going to accept that auto completion. So I'm going to say equals single quotation mark. You can use double as well. And I'm going to say the name of my file dot CSV, and I'm going to close that. And I'm just going to hit shift and return. So the grayed out text or the grayed out code, I'm not going to accept that. So just that. So what's happened there is the file that I want to use, and I'm just going to assign that to a variable so I don't have to type that long whole name again. I'm just going to use it. As it stands though, it's not going to work because that's just the name of the file. It's not telling me where that file is. So what I'm going to do, I'm just going to delete this, just highlight it and hit the backspace. But do remember that we copied the path. So I'm just going to hold down Command and hit V for copy, or Control V. And there we go. That is where that file is. /content /hottest.csv. That's where it really is. Now I'm going to hold down Shift and Enter, Shift Return again. Now it's properly saved. Now the next thing I want to do is to import this file. Now to import this file, again, get the AI to do it. We'll do that very shortly, but I'm just going to show you the code. So I want to import this CSV file, the spreadsheet file. And what I really want to do is not, again, use that whole name again. I want to just assign it to a variable that's short and easy. And the typical one to use is DF, stands for data frame. You can use any legal name that you want to put in there. By legal, I mean don't start it with a number, don't have spaces in it, don't use one of the built-in Python functions or keywords. DF is very safe, short for data frame, which is exactly what we want to do. This time I am going to accept this code that Gemini suggested. So I'm going to hit the tab key and that's it. And by now, you should know what this is going to do. The PD, remember when we imported that pandas as PD, that's the pandas package. That's the one that imports and manipulates data. So that's great. The dot notation, and then this function that lives inside of this pandas package. So the read underscore CSV. And then as an argument, I give it the variable file, which is now assigned to the string on the right hand side, which is actually the file that I'm interested in. So you can see Python code sort of reads like English. It's not that difficult. I'm going to hold down Shift and hit return, and a little green check mark. My file is now there. It's now live in the session. I can actually use the data. Let's create a little text cell. And so what I'm going to type here is the following. The info method, and again I'm putting that in little tick marks because that is actual Python code, and I'm just formatting that so it just stands out a little bit. The info method returns information about the data file. So a method is You can think of it as a function that applies to an object. Now we've already created this object called df. It is a data frame. This read_csv file imports your spreadsheet and it creates a data frame object. And so I can just refer to that object. So again, I'm not going to use AI. I'm just going to type this for you, df.info. And open close parentheses. The open close parentheses are telling us that this is a function, but it's a function that applies to an object that already exists, and so we call it a method. So I'm going to hold down Shift and hit Enter Return. The code executes and I can see information about this df object. We can see it's a pandas.core.frame.dataframe object. So that's where I get the name from. It's a data frame object. It's got 918 entries from 0 to 917. Very important here, two things. Number one, it's a sanity check because I might know that I have 918 subjects in my data set. So nice sanity check. Another important thing, you can see 0 to 917 is because Python is a zero indexed language, meaning it starts counting at 0. The first item would be item number 0. The second item would be item number 1. Now that's slightly irritating for some people. It's just the way that Python works. It's zero indexed. And there we can see the columns. So the first column would be column number 0. It's called age, and it's got 918 non-null values. So it's very important for us to see here if there are any missing data. We can see 918 across the board for all these 11. Remember, 10 would be number 11. For these 11 variables, so 11 columns of my spreadsheet, there's no missing data. That's fine. The final one's kind of important. It looks down that column and it looks at all the entries in every row in that column, and it looks like at the data type of the values that were entered there. Int 64 is 64-bit integers, and an integer is like a whole number, and it means down that H column there were only numbers typed in. No one made the mistake of typing 50, F-I-F-T-Y, because that won't be a number, that's a string, that's just text. But it hasn't found anything like that, and again, it's a very nice sanity check. It means that probably no one entered anything too incorrectly. It's one of the first sanity checks for our data entry. For the second column, which has an index of 1, remember now, it's called 6, it's got no null values, all the values are there, 918 non-null, and the data type is object. Now object is the keyword for strings, for categorical variables. And so probably down there is going to be, binary, like something like M and F, and we're going to look at that a little bit later. But it is an object, and that just means strings, and for our purposes in statistics, that's going to mean a categorical variable. If we look further down, we see int64, object, int64. You might see something like float64. Float means there are decimal places in those numbers. And so that is a good sanity check. The final sanity check I'm going to do is just to print out the first couple of rows. So what I want to do is just to add a new text cell. I'm going to type the head method returns the first 5 rows of the data set. By default, you can add another number as an argument, but if you just leave it blank, it's going to do 5 rows. So let's do that. Again, I'm just going to do it by hand. df, the object already exists. Dot, I'm going to apply a function to this object that already exists, and it's the head method. So I can just do head, open close parentheses. I'm just hitting tab because Gemini created the code for me. I'm going to hold down shift and return, shift and enter, and there we can see nicely formatted the first 5 rows of data. Row 0 is the first row to row 4, which is the 5th row. We can see age, sex, chest pain type, breasting, BP, cholesterol, etc. And so right to the end, heart disease 0 and 1, 0, 1, 0. And obviously those are encodings for this first person did not have heart disease, the second person did, that person didn't have heart disease. So it's something that we will have to fix. If we want to use, for instance, a plot, we don't want to write 0 and 1 on the plot. We want to say no heart disease, heart disease. So kind of things that we have to think about. And my sanity checks are now complete. So if we look at this, we've got a nice, neat research document. We've got nice documentation. We've written some normal English sentences to describe what's going on. And you can add a lot more information. So typically, over here, I'll add a data dictionary. I'll have a new text cell here, and I'll say something about each of these variables and what they mean. So when someone else in my research group reads this, they can see what these variables mean. So, and for instance, the 0 and 1. What does 0 mean? What does 1 mean? Those are just encodings for no heart disease, heart disease. So that's very important to have that. And so you can add as much detailed information as you want by just adding more text cells. So that's our first demonstration of using Google Colab and Gemini. In the next video, we're going to do some univariate summary statistics.